Hey everyone, welcome to Amazon SageMaker AI Science Corner videos, your go-to location for deep data science and large language model content. My name is Pranav Murthy and I am a senior Gen AI data scientist. I work on the Amazon SageMaker AI team. I love building intelligent and autonomous systems. In this video, we're going to focus on large language model knowledge distillation technique and how you can use knowledge distillation to generate faster and more efficient small language models that are also domain experts. Let's get introduced to knowledge distillation. Today, we have access to some truly massive and incredibly capable large language models like Anthropic Claude, Amazon Nova, the Llama 4 series, and many more. These models excel across a wide range of business domains, for instance, finance, healthcare, automotive, and can handle a lot of different nuanced tasks like classification, optimization, text generation, and many more. But in reality, we don't always need a gigantic all-knowing LLM for every use case. For many simpler tasks like name entity recognition, topic classification, document summarization, or even just straightforward Q&A, we can use a much smaller model like the ones that range between 1 and 10 billion parameters like the Llamas, the Mistral, and the Quins. These models are efficient, cost-effective, and fast, making them a practical choice for a lot of different types of applications. However, there's a catch. Smaller models don't always have the deep domain expertise that larger models do. For example, a 7 billion model might do a decent job at general medical Q&A, but it could miss the nuance in radiology report interpretation or struggle with complex financial compliance scenarios, areas where a large model truly shines. In practice, what we often need is the depth and intelligence of a large model, but laser focused on a specific domain like finance or healthcare, insurance, automotive, etc. Sometimes it's even narrower. Think of a financial loan approval assistant, a medical document writing copilot, or even an insurance underwriting automation tool. Something that I've been using very often is a trip planning assistant. Here, we want a smaller model to think like an expert, but only within a tightly defined scope. So, how do we make smaller models this specialized? How do we transfer the rich knowledge and subtle expertise of a large language model to a more lightweight model that's easier and cheaper to deploy? The quick answer is knowledge distillation. A little background. Knowledge distillation was first introduced by Geoffrey Hinton and his team way back in 2015 as a way to transfer knowledge from large complex models, the teacher, to smaller, faster ones, the student. While the concept started with image classification, it's since become a key technique in NLP and large language model, meaning it's directly applicable across different input modalities. Today, we'll focus on distillation for text generation tasks. Our goal is to generate a synthetic data set using a specialized domain data. In this example, we'll use a finance-related use case where we structure each sample as a question, context, and answer. Just like an expert would, we'll use a teacher model to produce these response examples, then fine-tune a smaller language model on this high-quality task-specific data. This way, we can build a nimble, specialized model that brings much of the big model's intelligence to a focused problem without the massive computation bill. Additionally, the synthetic data we generate will have reasoning capability of a larger model distilled in so as to teach a smaller model efficient reasoning. In this example, we're only going to leverage the instruction or the question column from the sample dataset and allow a larger model of choice, any model that you'd like to choose, to answer the question, which will then be distilled onto a smaller model like a Llama 3 billion or a Quen 1.5 billion model. So what's really happening under the hood with knowledge distillation? At its core, distillation is about transferring the behavior of a large teacher model to a smaller student model. The key is that the teacher outputs soft targets or probability distributions over all possible answers, not just the correct labels. For example, in classification, the teacher might predict 70% radiology report and 20% discharge summary and 10% others, rather than just one hard label. During distillation, the student is trained to match these soft targets using loss function like Kullback-Leibler divergence for classification or cross-entropy loss for text generation. These losses encourage the student to capture the nuanced knowledge and uncertainty of a teacher, and not just the final answers. With LLMs, this extends to generating full responses or step-by-step reasoning. The student learns to mimic these richer outputs, making it possible to train high-performing specialized models with much less data and compute. In short, distillation lets us compress the expertise of a large model into a smaller, more efficient one, delivering near teacher performance, but with lower cost and faster inference. Before we get started with large language model knowledge distillation, we're going to need a cloud IDE backed by a right-sized compute and storage to follow along. I typically like using Jupyter Lab IDE, and the fastest way to get one is from your Amazon web console. I'm going to now search for SageMaker AI, and all I need to do is just create a very quick domain. So set up for a single user, and I click setup. I just wait for the domain to get up and running. May take a minute or two. And once the domain is up and running, you should see the domain is in service. So I'm just going to launch the domain. So I need to click on the domain, get to the user profile, and hit launch. And here it gives me access to Studio. So now I launch into SageMaker Studio. And from here, it's one extra click to get to Jupyter Lab. So I'm going to click on Jupyter Lab. I'm going to create a new Jupyter Lab space, give it a name. I'm going to call it Demo LLM KD. And then wait for the initial instantiation of a space. Now, the options that Jupyter Lab space allows me to configure is I can back it by the right kind of instance I need. If I know I'm going to be running mostly CPU-based workloads, then I can choose any of the T, M, or C-based instances. If I need accelerator-backed instances, then I have the option to choose between MLG instances or P instances. So I have GPUs available for interactive workload. For this example, I'm just going to choose a T3 medium, and then I'm going to up the storage to 15 gigs and then hit run space. This is going to take about 15 to 45 seconds. And then when it's ready, you will have the ability to launch a new space. I have one already pre-provisioned, so I'm just going to click open. And voila, you have your Jupyter Lab notebook space ready to go. Now let's talk about how you can actually perform knowledge distillation using SageMaker AI. The process is pretty straightforward and can be broken down into a few clear steps. First, selecting a teacher model to generate high-quality responses. This is a very important step. For today's demo, I'm going to be picking DeepSeek R1 Quint 30 billion parameter model as our teacher model. One thing to note is it's always best practice to review a model's license and terms of use, just to see if the model provider allows or prohibits the use of model's response for distillation purpose itself. Okay, now let's take a look at how we can deploy a teacher model. So the first thing we're going to do is navigate out of Jupyter Lab space for just a quick minute. I'm going to go into my SageMaker Studio UI. I'm going to scroll down. You can see Jumpstart right here, and you're going to see a lot of models available. Most of these are open source models that are available and deployable securely through Jumpstart. You do have the option of a few closed source model providers models as well over here. But for this example, we can just stick to DeepSeek. I really like DeepSeek's reasoning capabilities, so that's what I'm going to choose. Now, in DeepSeek's model card, you can see the options you have access to DeepSeek R1, the most recent DeepSeek R1, the May edition, or you have the distilled variant itself. For this demo, I need a right-sized model that can answer questions where the theme is not very complex, but also I need proper reasoning capability. I needed to get the answers right. So for that, I think that Quint 32 billion would be the right size model for deployment. So I'm going to select that. But in your practical use case, you can just as easily select DeepSeek R1 model and get the best reasoning capability, or even choose Llama, Scout, or Maverick model from Jumpstart as well. So deploying from Jumpstart is very easy. You can choose to deploy this using API-based actions. You even get a cookbook readily available that you can simply click and launch. For this, I'm just going to use the user interface because it is very simple. I'm just going to click on deploy. And then I have two options. I can either create an endpoint name that I want. For this, I don't really care, so I'll just choose the auto-generated name, and I get to choose the instance type. So for this example, I'm going to choose G5 48 extra large because it is a pretty big model. And then if I want to, I can update a few advanced settings, and I can roll this endpoint under a VPC configuration. By default, network isolation is enabled. I can even update the tags if I want to, and just click deploy. And with that, you're going to have a model ready in maybe 6 to 12 minutes. It just depends on a few things, but I already do have a model ready to go. So I'm going to end up using that for the demo purpose. And I have another model which is exactly the same DeepSeek R1 distill variant that I'm going to now demo with our distillation script. Next, we need a framework that can coordinate between our teacher model and our sample dataset to automate the process of generating these responses. For this, I'm going to choose Distillable framework, but you can choose any other framework that's commonly available. Amazon Bedrock has a built-in distillation method end-to-end as well. But for the demo, we're going to restrict ourselves to just the script that is interacting with Distillable. So let's take a look at how that's built. So in our script, we're just using Distillable, no other fancy packages. We have a simple upload to S3 at the end of the job. We have a bunch of artbus, which we'll get towards the end. This script also has integrations with MLflow, and I'll explain in a quick minute why that is important. Now, the definition of Distillable is very simple. Amazon SageMaker endpoints, you can interact with them using Light LLM. And Distillable has a direct integration with Light LLM, where you can just specify the model URI and then the generation quarks at runtime with the temperature, max tokens, top P, top K, etc. And you can supply a data set and get started. Now, this entire run is wrapped with MLflow. For those of you that are not familiar with MLflow is a framework that helps us track experimentation. We can log values, data sets, metrics. So it makes it very easy for us to recreate experimentation, and it's integrated into model registry. So if we need to recreate that particular model, for instance, if I have a teammate that's going to work on this again, and he or she needs to recreate this model, then they'll be able to simply reference to that model and the MLflow run to get all the parameters and hyperparameters that are required, and they can rerun it again. So the process is fairly simple. Now let's take a look at how we actually run the script. So we have the script name, which is data distillation simplified. The model URI, which is the important piece to take note, is SageMaker hyphen tells Light LLM to now talk to SageMaker endpoints and not just any arbitrary endpoint name. And then you follow that with the Jumpstart nomenclature. So where do you get this endpoint name? There are two ways you can get that. So go to your SageMaker Studio UI. You scroll all the way down to deployments, go to endpoints, and you can get the endpoint name right here. So I've already copied mine. Now you can also specify the experiment name under which you're going to roll up the data generation process. Other than that, you can supply the dataset JSON, the destination dataset JSON, also the instruction alias column that you're going to use. Let's take a quick look at the dataset itself here. You have a column called as open-ended verifiable questions, which contain a system prompt at the top, followed by a set of context, and then the question itself. So this is the instruction that we're going to provide our teacher model so that it can generate the answers. Now, one thing you may also observe is that it has the ground truth column here, which means that the answer has been verified, which you can use within your own process to also verify your teacher model's output. It is rare that you can get a data set with ground truth answers. If it has, then the process becomes extremely straightforward. If it doesn't, then you might have to use complex methods like LLM as a judge or a human reviewer to actually validate the data set. Now, in terms of actually running the data set, you can just simply copy at the top, ensure that you've changed your parameters. And I have a Conda environment with all the packages installed, and I can just kick the job off. Now, this is going to take maybe 30 seconds to 45 seconds for this to run. In the meanwhile, I actually have a demo ready to go. I ran a sample for about 10 instructions. Now, let's take a quick look. In this, you can see that you have the instructions as you saw in the Hugging Face dataset format. No changes there. Now, optionally, you can add additional suffix or prefix prompts to this and make it more personalizable and make it more specific or targeted to the use case. And the generation right here, as you can see, you will observe a think tag right here. This think tag implies that, the Quen has thought through before answering the question, and then the response is right here. So that means that it is thinking through. Now, this is a very important piece. A student model, like for instance, if I use Llama 3 billion model, it doesn't have reasoning capability natively built in, which means that the output generated by Quen is going to be used to distill and train a smaller model like the 3 billion model, and the loss that is computed at runtime, that would be a distillation loss. So we're doing a staggered two-step process in order to get to the final distilled model. So here's a new output that also got generated for this run. And you'll be able to see how the Quen model thought through before answering the questions. Now that we're confident that the process works, we want to be able to run this process in a headless manner so that, we're not waiting for the process to be running inside a notebook. So my suggestion is you can take the existing script and then wrap that up inside SageMaker processing job and kick it off in a distributed manner. You can either have one processing job, just continuously run and collect the teacher model responses, or you can have multiple jobs all run in parallel and hit the endpoint and collect the results. So it just depends on how fast or if you want to run the process sequentially. With that said, I think we're ready to proceed towards fine-tuning a smaller LLM with the dataset that we have generated. I'm going to choose a smaller LLM like a Llama 3 to 3 billion model to not only teach reasoning, but also improve its financial domain expertise based on the dataset that we just chose.